Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
We electronics engineers, this is our overcoat. How about mechanical engineers or chemical engineers? You can put on your overcoat to really insist that you are ready to advance or you are ready to solve real life engineering problems. Okay? So again, I would like to welcome all our national and international undergraduate students into departments of higher engineering, scientific mathematics. The module name that will teach you, or the course name, is called Probability and Statistics. This course in Tanzania is being taught on in most institutions, colleges, and universities in the world. Is being taught to the second year Bachelor in Engineering or Bachelor in Science students. We are in Chapter 3. This is called the Statistical Estimation, and this is Lecture 7, when we will teach you about confidence interval for sum and differences of the two samples. So you have to stay tuned and stay focused. Okay, so let me do the quick review of what? Let me do the quick review of lecture 6. So in lecture 6, we taught you about confidence interval for proportion. It will be focused on the finite and infinite proportion. So basically, we taught you that confidence limit is equal to what? Probability of success plus or minus the error. Again, we taught you that confidence limit at the particular interval. This also is given as probability of success plus or minus the error is standardized value at critical value times standard deviation of proportion. Standard deviations of what? Of proportion. Then we have been focusing on the infinite population. So we have told you that for infinite population, confidence limit about proportion, confidence limit about proportion, this is given as probability of success plus or minus standardized the value at critical value, then multiply by what? So multiply by standard deviation, square root of products of probability of success and probability of failure over sample size. That is for infinite population. For finite population, confidence limit about proportion. This is equal to probability of success plus or minus standardized the value at critical value. Then you have square root of what? Probability of success times probability of failure over sample size. And then we have what? Square root of what? Square root of population size minus sample size, then population size minus 1. So this is the formula that we have taught you to focus. Another formula, probability of success plus probability of failure is equal to 1. So if you are looking, probability of failure is equal to 1 minus probability of success. Another formula that we told you, probability of an event to occur is equal to number of events of a number of sample space. Then we left the homework for you. I believe that you're doing it. Let me do the correction. Not the correction, I won't do the correction. Simply, I will just give you the answers. So, answers for homework 60. We had left example what? Example 15, page 15. Example 14, B. So example 14B, he asked to find the confidence limit for 99%. So the confidence limit for 99%. So for 99% is what? 0.55 plus or minus. 0.55 plus or minus 0.13. 0.13. Then solution for example 16. Example 16. The confidence limit is what? Confidence limit is what? Is 0.5 plus or minus 0.15. Plus or minus 0.15. 0.15. That's the confidence limit. Yeah. So that's the solution. Check yours. If you've got you've got these responses, then congratulations. If you missed it, don't worry. Keep trying. So today I want to teach you about confidence intervals for sums and differences. Say with me. Confidence intervals for sums and differences. So listen carefully. If S1 and S2 are there two samples drawn from population from two different populations, or from two populations, then the confidence limits of S1 of sum or difference of what? Of two samples of two populations can be approximated at a particular interval. So the concept here is we have two populations. Listen carefully. when we talk about sum and differences or confidence interval, or first of all, before we talk about confidence interval, when we talk about sum and differences of the two samples, we say that suppose we have population 1, and also suppose we have population 2. So you have population 1 and you have population 2. So this population 1, we can draw the sample. So this is sample 1 from what? Population 1. And also in this population 2, we can draw the sample. This is sample 2. So we can find that in sample 1 we can find the statistical mean 1. In sample 2 we can find the statistical mean 2. In other words, we can also find variance for what? Variance for the sample 1, and also we can find variance for sample 2. We can also find proportion for sample 1, and also you can find proportion for sample 2, which is probability of success. At the point that we'll be focusing. So because we have two samples, and then we say one to estimate the mean, or one to estimate the proportion of the two samples, of the two populations by using the two samples, then from there we have to find the sum of the mean or the difference of of means. We introduced to you this concept in chapter 2 that's called the sampling distribution. But in this case, we want to add add value of what we have introduced it to you. Okay? Suppose that the population, the sample drawn from first population has what? Statistical mean, standard deviation 1, variance 1, and the proportion 1. Okay? Then again we say that suppose the sample drawn from second population has statistical parameters. So you have statistical mean 2, proportion 2, standard deviation 1, not 2, and the variance 2. At the point that you have to remember as great mathematicians. Okay. So from that fact, we say that, okay, that's fine. So now let us focus from one concept to the other concept. So recall this fact. Recall that confidence limit is given as what? Statistical mean. Okay, so let us start with confidence interval for the sum of two population means. Sum of the two population means. confidence interval confidence interval for what? Confidence interval of the sum of two population means. Of two population means. Of two population means. Confidence interval of the sum of two population means. The first step, we say that recall that confidence limit is equal to what? Is equal to statistical mean plus or minus error. And also remember that I told you confidence limit is equal to what? Statistical mean plus or minus sometimes divided critical multiplied by standard deviation, for this case of what? Of sum. So we are focusing of sum. So standard deviation of sum. Okay? So this is question 1. So you have to listen carefully. That's the general formula. So the second step, we say that, so this is standard deviation of sampling distribution of means. This is the general formula. Second step, so you say that confidence limit of two population or of two samples is what? Is, now we have two means. Okay, so confidence limit of sum of two of sum of so confidence limit of first population, we are sure that the mean of the first populations lies in this one of the first population is statistical mean 1 plus or minus ZC multiplied by standard deviation of sampling distributions of means 1. Okay? Then confidence limit of what? Of secondary population. Listen carefully. Second population is mean 2 plus or minus, so there's the divided critical multiplied by standard deviation of sampling distributions of mean 2. You have to listen carefully. So steady step. So this is the derivation. You should not claim these formulas. Derivation of what? Of formula. Steady step. Now we want to combine. Suppose that this is equation 2 and this is equation 3. So we want to combine equation 2. So equation 2 and equation 3. So confidence limit of sum of two population is this. Mean of the first population of the first sample plus mean of the second sample. This one have to plus or minus. So there is the value at critical. Then you have standard deviation of means of the first sample plus means of the second sample. This will make what? Equation 4. So this is the combination up there, if you understood. In case you have any question, don't hesitate to ask your questions in the comment section. Right? We are here to help you to understand. We are here to help you enjoy probability and statistics. We are here to help you to keep going and keep moving and keep thinking how you can solve the real life problems rather than thinking too much how you can pass the final exams or the continuing assessment of probability and statistics, and keep moving up on how you solve real life problems by using this concept. Okay? So from here, we take that, again, we got the first concept or the first state. The first state, we say that recall. But standard deviation of first mean of the first sample plus standard deviations of the second sample, this one, if you do remember, we taught you this formula in chapter 2 is equal to variance 1 over sample size 1 plus variance 2 over sample size 2. Okay? So this is what? This is question 5. You remember that if you forgot, just to review lectures, more than 10 lectures of chapter 2. Okay. So we go into the first state. The first state, we say that substitute equation 5 into equation 4. To substitute equation 5 into equation 4. So the general formula now of finding confidence limit of sum of two population, this is equal to what? Sum of sample mean 1 plus sample mean 2 plus or minus standardize the value at critical value. Then we have what? Square root of what? Variance 1 square over sample size 1 plus variance 2 square over sample size 2. This is the formula you have to remember whenever you are solving problems that will ask you to find the confidence limit of the sum of the two populations. Okay? Okay. So B, let me teach you the difference of this and then I will teach you about proportions. I'm trying my level best to simplify the contents that I'm teaching you for you to understand and go further as well as you can. So B, let me teach you how you can find confidence interval of difference. Confidence interval of difference difference of two populations. Difference of two populations. So derivation. So we have to continue with the first step. We can take equation 2 minus equation 3. So take equation 2 minus equation 3 or equation 3 minus equation 2. So from there we can find what? So of this one. So you can find confidence limit of what? Of difference of two population. This is equal to what? Statistical mean 1 minus statistical mean 2 plus or minus what are standardized value at critical value, then multiplied by what? Standard deviation of xc1 minus xc2, my mean of the second sample. Again, we got the sixth step. Suppose that this is equation 6. So suppose that is equation what? Equation 6. The sixth step. Recall that we told you standard deviation of sampling distributions of means 1 minus standard deviation of sampling distributions of means 2. I told you this formula, and like to recall it, is equal to what? Variance of the first sample over sample size 1 and variance of the second sample over sample size 2. So this will make it equation 7. Equation what? Equation 7. So the seventh step, substitute equation 7 into equation 6. So confidence limit of difference of two population is equal to mean of the first sample minus mean of the second sample plus or minus some value at critical value. Then you have what? Square root times 1 square over sample size 1 plus 2 square over sample size 2. So that's the general formula. Okay. So in case you have any question about confidence limit of sum of two population, or if you have any question about confidence limit of difference of two population, ask in the comment section below. Use the comment section, ask me. I'll try my level best under the grace of God to answer your questions in order for you to be sure on what you have captured, or you have kept it, or you have taken, or you have absorbed it from what I've been teaching you. All right? Do you understand what I've been teaching you? So let us go into the next part, where we'll be focusing on confidence interval of two proportion population. Proportion population. So here we've been discussing about so let us refer what we taught you in lecture 6. So confidence interval, before we solve problem, confidence interval of what? Of sum or difference. Differences of what? Of two population, of two proportion. Of two proportion. So confidence interval of sum or difference of two proportions. Of two proportions. Suppose that the first proportion or the first sample drawn from first proportion population has probability of success 1, probability of failure 1, sample size 1, and what? What else? Variance of proportion 1, no, standard deviation proportion 1, and variance of proportion 1. So these are the 5 statistical parameters. Is it right? Is it correct? Yeah. And the second sample drawn from second proportion population has probability of success 2, then probability of failure 2, sample size 2, standard deviation 2, and the variance of proportion 2. If that's the case, now we can focus on noting on confidence interval of sum of the two proportions. But the general concept, remember that after building this strong foundation in our mindset, So Roman C, confidence interval of sum of two proportion So recall what I've taught you in lecture 6, that confidence limit is equal to probability of success plus or minus error. So how many samples do we have? In this case, 2 samples. So you say confidence limit. So this is about what? Proportion. So you say confidence limit for first proportion. This is equal to what? Probability of success 1 plus or minus standardized devalued critical value multiplied by standard deviation of proportion 1. So that was equation 6, or equation what? Equation 7. So suppose this is equation 8. Again, confidence limit for what? For second proportion. Second proportion is equal to probability of success 2 plus or minus ZC standard deviation of proportion 2. So this is equation 9. So to get the confidence limit of the sum of the 2 proportion, we have to sum. Take equation. Okay, so this was 67 steps, so this is 8th step. So the 9th step, we say that let us take equation 8 plus equation 9. So what do you get? Confidence limit of sum of 2 proportion. This is equal to what? Proportion 1 plus or minus plus what? Proportion 2. This is plus or minus. Plus or minus what? ZC, standard deviation of proportion 1 minus proportion 2. No, plus proportion 2. The 10th step. From what we taught you in sample distributions as a second chapter, we taught you the standard deviation of proportion 1 plus proportion 2. This is square root of what? Product of probability of success 1 times probability of failure 1 over sample size 1 plus what? Probability of success 2 times probability of failure 2 over sample size 2. So suppose that this is equation 10 and this is equation 11. So take equation 11, substitute in equation 10. So you say substitute equation what? 11 in equation 10. So confidence limit of sum of two proportions is equal to probability of success 1 plus probability of success 2 plus or minus. So there is the value at critical value, which is C, and then this is what? This is probability of success 1 times probability of failure 1 over sample size. That's what? Probability of success 2 is probability of failure 2 over sample size 2. This is the general formula that you have to remember. Okay? D. Confidence interval. Confidence interval of difference of two proportions. Of two proportions. So this will be 1260. Let us take equation 8 minus equation 9. So from there, we get what? Confidence limit of difference of two proportions is equal to what? Probability of success 1 minus probability of success 2 plus minus standardized the value C multiplied by standard deviation of proportion 1 minus standard deviations of proportion 2. So this will make out equation 12. Question 12. These formulas are very important. You should not cram. One of my weaknesses is cramming. So how do I remember all of this formula? I have just to remember where should I start. The fundamental formula for me it is. It's better for me to spend at least 3 minutes to derive the formula rather than cramming. And that's not good for engineers because engineers and scientists are responsible to solve real life problems. So if that's the case, we say that the 13th step, you have to recall what we taught you also, that the standard deviation of proportion 1 minus proportion 2 is equal to square root of what? Probability of success 1 plus probability of failure 1 over sample size 1 plus what? Probability of success 2 times probability of failure 2 over sample size 2. So this is equation 13. So substitute the next step, you substitute equation 13 in. So substitute equation 13 in equation 12. Confidence limit of difference of two proportions. This is equal to what? Proportion 1 minus proportion 2 plus or minus standardized value as critical value, which is C, then square root of what? Product of probability of success 1 times probability of failure 1 over sample size 1 plus what? Probability 2, probability of failure 2 over sample size 2. This is a very important formula. So regardless whether you are dealing with standard deviations of sum or differences, it's the same in sampling distributions of mean and also in finding proportion. Okay? So remember that. So after having this formula, now let me put a problem on the blackboard in order to apply this concept, and you'll see the applications of the concept that I have told you. Then I will give you the homework for you to have on your own. Are you ready for question? Are you ready for example on this part? If you are ready, then let me introduce to you, ladies and gentlemen, example 17. Example 17, and this is concept. It's a kind of a long question, but it's not difficult. For solving that question, so I'll give you the homework. Yeah, then we'll be in good position. A research team in the difference between serum uric acid levels in patients with and without Down's syndrome in a large hospital In a large hospital, in most of the lectures, many teachers, they don't insist this. For the treatment, in a large hospital, for the treatment of the mentally challenged, sample of 12 individuals in a large hospital for treatment of the mentally challenged. A sample of 12 individuals was down 20 individuals with Down's syndrome, yielded a mean which is x1 bar is equal to 4.5 milligram per 100 milliliter. That is a finding in a large hospital. The finding in the general hospital a sample of what? A sample of 12 individual, sample 15. Sample 15 of normal, sample of 15 in a general hospital, a sample 15 normal individual individuals of the same age and sex were found to have a mean value of x2 bar, which is equal to 3 and 4. Some of the question statistics are long. If it is reasonable to assume that the two populations of values are normally distributed. With variances equal to one and 1.5. Find the 95% confidence interval. Confidence interval for difference. Find the 95% confidence interval for differences. That's the question we have. Copy the question and let us read what has been stated. After this question, I will give you the homework. Today, I will just solve only one question, and then because I prepared 2 questions, one I will solve for you and the other ones I will give you the homework. So let us read together. A research team in difference between serum uric acid levels. So this research team, it was observing, so because you have copied, so I can write, it means I can highlight some keyword. So a research team in the difference. So it was researching the difference between ceramic uric acid levels in patients. So there are 2 patients. Patients with Down's syndrome and patients without Down syndromes. So they did research in 2 hospitals, in a large hospital and general hospital. So in a general hospital, they took a sample. So in a large hospital, for the treatments of the mentally challenged, a sample of 12 individuals. So a sample of the 12 individuals with Down syndromes yielded a mean of 4.5 milligrams per 100 milliliter. Then again, they did another research, or the same research, or they took a sample from a general hospital. So in a general hospital, So in a general hospital, a sample of 15 normal individuals. So the sample drawn is the second sample. Normal individuals of the same age and same sex were found to have a mean value of 3.4. If it is reasonable to assume that the two populations of values are normally distributed with variances equal to 1 and 1.5, find the 95% confidence interval for differences. So the difference between questions of difference of sampling distributions of means and difference of in sampling distribution and questions of statistical estimation is the last sentence, 95% confidence interval. If you be given the same question without this part, then you have to treat the questions as how we taught you in chapter 2. But because we have that, then you have to treat these questions as how we used to teach you in chapter 3, which is statistical estimation. Should not panic, should not worry. Imagine that you're being given, if you've been given a question like this in exam, most of past papers that I've reviewed, you may be awarded 7 marks. Okay, 7 marks, 8 marks, or 10 marks. It's not difficult the way it is. The way it is, it seems like it's difficult, but really, it's not a difficult questions. I'm going to guide you. Are you ready for that? But remember that we are using the active learning technique. You can pause the video and try to solve this question yourself. Right? Can you do so? You may do that. Try to solve this question yourself on the graph paper before you check my solution. Thank you for trying. Let us solve together. Solution. The first step, we say that identify the given data. Identify the given data. For the first sample, you'll be given a statistical mean, which is 4.5 milligram per 100 milliliters. Also, we are given the sample size, which is N1, is equal to 12. So only 12 patients have been taken from the large hospital. But also its variance, because here there is a missing word which is respective, with variances equal to 1 and 1.5 respectively, so that the missing one there, if it could be the one who is asking this question. Okay, so the variance 1 is equal to 1. This is for the first sample. For the second sample, mean is 3.4 milligram or 100 milliliters. Sample size is 15. Then variance is what? Is 1.5. It's 1.5. So what's required? So then confidence level of two samples is given as what? 95%. So what we have asked, confidence limit is what required. Second step, the question is asking you about finding confidence interval for the difference between two populations, between two samples. So recall what I told you, that confidence limit for difference of two samples is equal to x1 minus x2. Then we have plus or minus zc and square root of variance 1 square over sample size 1 variance 2 square over sample size 2. The third step, we ask you to find out ZC corresponds to 95%. We told you, refer the chart 4 and 5. So we told you how you can find the C for that correspond to 95% is 1.960. How do we get this? It's not difficult. You just have to take it. So 95 means you have to find that corresponding to what? To 95 over 100, then multiply by 2. Simply, you have to find the 0.4 So this one minus what? Minus 0.05 over 2. So that C corresponds to what? So this is 0.95 over 2. So this corresponding to probability of what? 0.475. So if you use table 4, table 4.4, you have your table 4.4. Answer is 1.9. So we're looking for 4.75. Yes, the answer is this one. 0.4750. The answer is 1.96. So use table 4.4. So let's see, it is 1.96. So if that's the case, the first step now, we can compute confidence limit is equal to what? X1 is 4.5 minus 3.4 plus or minus ZC, it is 1.96 square root of what? Variance 1 is 1, sample size 1 is 12, variance 2 is 1.5, sample size 2 is 50. Is it? Yeah. So confidence limit for the difference of two populations. So use your scientific calculator to do the computation. The response will be what? (1.1) plus or minus 0.84. So therefore, confidence limit of difference of two populations is 1.1 plus or minus 0.84. That's the final response. Okay, so check your trial. Did you get the right answer? You can express also as the interval. The confidence limits the interval. So you should not worry. Okay, so if that's the case, while you're meditating about example 17, let me give you the homework. Let me give you the homework. So this is homework 7. Example 18. It's not long, like the one that I gave you, or I solved for you. It's short, but it's very interesting. In a random sample, if you have any question, don't hesitate to ask in the comment section. In a random sample of what? Of 400 adults and 600 teenagers who watched a certain TV program. (100 adults and 300 teenagers indicated that they liked it. Construct the 99.7% confidence limits for the difference in proportion of all the adults of all the adults and all teenagers. And all teenagers watch the program and liked it. That's the question. In a random sample of 100 adults and 600 teenagers who watched a certain television program, 100 adults and 300 teenagers indicated that they liked it. Constructed the 99.7% confidence limits for the difference in proportions of all adults and all teenagers watched the program and liked it. Ladies and gentlemen, this is the end of lecture 7. I would like to invite you to join me in lecture 8 when I will teach you about probable error. And afterwards, possibly I can do corrections for this question, and then I'll teach you probable error, and then I'll start teaching you about sampling, small sampling theorem. Okay, I'll start teaching about students' t-distribution. I'll teach about chi-square distribution. Teach about confidence limit, how you can find confidence limit, and etc., and F distribution. So we still have students' t-distribution. We still have chi-square distribution. We still have F distribution. So until we meet in the next session, this is Olenjolaim from beautiful country Tanzania. I would like to leave you to keep meditating. Review this video several times as well as you can until these concepts has been written in your subconscious minds. Remember that the vision we have in online undergraduate Polytechnic Institute of Tanzania is to equip our students with relevant knowledge, understanding, and wisdom that can help them to solve real-life problems. So stay tuned and stay focused and stay enjoying the beauty of higher engineering and scientific mathematics. And the module of the day is called the probability and statistics that is well taught at the Institute of Technology for all undergraduate second year students or third year students, because at the IT we have students who are doing engineering programs, different engineering and science programs for 3 years, and others are doing for 4 years. So this module is taught in the second semester of the second or third year of undergraduate studies in different engineering programs, including laboratory science and technology. Don't forget to subscribe in order for you to get notifications when we upload or we publish lecture 8. Make sure that you share these contents with some of your friends or with other students who like to enjoy the online contents and who like to understand and master the beauty of probability and statistics. May God bless you and keep you until we meet in the next session. Keep enjoying high engineering and scientific mathematics.